good afternoon and welcome. Obviously, let me begin by thanking Mark, thanking him for taking his time to come to Stockholm and support our annual meeting. Very gracious. It's great. And of course, thank you for adopting life cycle energy analysis of cylinder blocks as one of your research topics. You're right that, SinterCast first published a report on life cycle analysis of cylinder blocks back in 1994. And we've used that report frequently in our customer presentations and at conferences and in technical papers. We renewed our role in that last year. Many of you know the editorial that we wrote in Automotive Engineer. And Mark and we met in June at the GIFA, as he said. The next thing that came out was the paper, which came out in July, and we had good discussions over that. And so I made my first visit to the university in August. And we've worked together since then and kept contact. Mark has referred to the project and also to the students. They're his students, but they're our students. They're a wonderful group, 7 people from 6 different countries. And some people in the UK do talk about immigration potentially as an unwanted or a bad thing, but these kids could do nothing but good for any country. Very hardworking, very capable. Certainly they have better technical skills than I did when I came out of my engineering degree, which was 1981. 84. I started in 81. Working very hard. So I learned a lot about what a group can do. And as Mark said, perhaps I was a little bit skeptical if the project could be done so quickly. But there is a real power in a group, and not only the power of the group, but also of their work ethic. So I give my thanks to you on behalf of the company and the shareholders, and also my thanks to the students. Yeah, really, really good project. We look forward to seeing the results later in the year. So let's begin the presentation then, as we always do at this meeting, with a review of our series production. And the production is good. We see the trend here from 2007 to 2015. And how good depends a little bit on where we measure. At the end of last year, our year-on-year growth was 14%. At the end of the first quarter, it was 7%. You know, the first quarter was always going to be a tough comparison. Last year was record everything. We had record production, record sampling cups, record installation, and also record revenue. So, you know, where do you go from that? But despite that we had such a high starting point, we can see from the graph here that the production has flattened in the last few quarters. There's 3 reasons for that. One is that some of the programs have ramped up to mature volume, so they give us a good stable contribution now, but we no longer have the ramp growth. There are a few programs that are down. You know, we have more than 60 programs in series production. The vast majority of them are stable or growing, but there are a handful that are low, and all of the growth that we can do in the other programs just helps to offset that and keep us flat recently. And I'll talk a little bit about that later. And the other thing, the third thing, is that we've had more variation than normal. In the last few quarters, we've always had one lower month that has affected the average. And that is something that's new for us. If we could put 3 good months together, the current programs have the potential to deliver about 2.5 million engine equivalents. So we see that as the potential of the current production. Also in this meeting, we always look at the compounded annual growth rate. And here we can see from 2007 until present, we have a compounded annual growth of 19% per year. And of course, the 2015 to 2016 based on first quarter is 7%. So that gives us an average of 14%. Last year when we were together, our average compounded growth since 2007 was 18%, so it's down a bit. And there's 2 reasons for that. First, of course, the production is higher. So as the denominator gets bigger, it's more difficult to have the same percent of growth. I mean, even if you have the same amount in absolute terms, the percent will be lower. And secondly, as I say, this flattening, which prevents us from having a higher comparison today compared to previous years. But we're absolutely confident in continued growth. As I said, the current programs could get us to 2.5 million. Then we have the programs that are approved for production by the OEMs and already awarded to SinterCast foundries. And those high confidence programs will be able to grow us up to about 3 million engine equivalents per year. And those are the programs in the development pipe that are approved. Of course, there are other programs that are also earlier in the development stage, and they will also come to the end of the pipe in the future. When those programs come on stream, it will help to pick up the growth trend and also pick up the compounded annual growth. Also in this meeting, we normally look at the production of the first quarter, and here we can see first quarter volume since 2010. The interesting thing in this plot, the first thing to see is that the first quarter of 2016 is the first time we've ever entered into a year above 2 million. And that high starting point will help us through the entire year. Even if we're a little bit flat and a little bit bumpy at the moment, we're flat and bumpy at a really high level. Yeah, and we'll benefit from that throughout the year. We can look at each of the different categories, and beginning with cars, we see the percent of our volume from passenger cars in 2015 and now in the first quarter of 2016. That has grown from 54% to 61%. It's because cars overall are up. A lot of that has come from the petrol engine, the Ford petrol engine in North America. It's been a really successful program for Ford and for Tupi in Mexico, and also for us, of course. Tupi, in fact, will be making a presentation about this good success story at the Mexican Foundry Conference next month. All of our other programs are strong and stable. We frequently get questions about the Audi program. I don't want to disclose volumes about any individual program, but there has been no reduction in Audi. Indeed, the current production on the 3-liter V6 is higher than the historical average, and it has been for the last few quarters. So no negative impact whatsoever. We can also look at trucks. Trucks are down a bit. Again, most of the programs are growing, but we do have one program that has declined. That program is being transferred from one SinterCast foundry to another SinterCast foundry. So we've had the ramp down and the stop at the first foundry, but we haven't yet had the start of production at the second foundry. So at the moment, we're a little bit in the low point of that valley. And, you know, we expect that as the production ramps up at the new foundry, that will help to recover some of the truck volume. We still regard trucks as our biggest long-term growth opportunity. And if you look at the recent installations, 5 of the last 6 installations have been in truck foundries. So that's a real indicator of the growth. So down at the moment, but still a really big growth opportunity and positive outlook. We can also look at other programs. And when we refer to other programs, we mean passenger car programs other than cylinder blocks and also industrial power. Last year, we talked about industrial power. And we mentioned the General Electric locomotive engine as being the real workhorse in that category. It's by far the biggest program. Last year, it was the only locomotive engine that had passed 2015 emissions legislation. And so it had exclusive access to the market. What has changed in the meantime is that other engines have also now been approved for the new emissions level. And at the same time, the rail market has gone down a little bit. So the volume on that biggest program is lower. And also many of you will know that mining and agriculture and off-road is difficult at the moment, both in Europe and in North America. But despite that that's a difficult market, we've had new programs come on stream. So we have the Cummins, if you recall the big QSK, the stationary power engine. That is actually being used in trains now, in Siemens trains in North America. We have a cylinder head for Deutz for tractors, and also a cylinder head for MTU used in mining trucks. And outside of that vehicle area, also we've ramped up the production of the piston rings for the large marine engines, which are made here in Sweden. So all of those new programs have ramped up, and they have fully offset the decline in General Electric. So industrial power is actually flat compared to last year. So a really good job to recover that change. As you can see, others this year, it's 7% of our total. We always want to try to keep that in the neighborhood of 10%. It is equally divided, so we can say something like 4% each. So even if one of those sectors was cut in half, it still wouldn't have a big impact on the total. But I think that industrial power has done a really good job to hang on to its absolute volume this year. What we can see from the top right corner of this overhead is that we are 61% passenger vehicle. So let's look at passenger vehicles in more detail because that's our biggest activity. Here we see the latest sales data from Automotive Automotive News in North America. And as in the past years, we see that the top 3 best-selling vehicles are the pickups from the Detroit 3, the Ford, the General Motors, and the Ram. Yeah. And what's fun to look at in this diagram is that the first vehicle, the Ford F-Series, it's actually double, almost exactly double of the best-selling passenger car. And frequently people ask, will this pickup sector continue to be so popular in America? And yes, it will. All of the forecasters generally agree that this will remain a dominant sector. Today in North America, the passenger vehicle sector is 41% car, 31% crossover, and 28% pickup and SUV. And we can look at the pickups in more detail. As I say, most forecasters regard it as being the dominant field in North America, at least to 2020, and that these will stay as the top 3. There are 5 different vehicles, the Ford and the Chevy and the Ram, and then the Toyota and the Nissan. In total, 12 different engines available in those 5 vehicles, and we'll look at them in more detail in a moment. SinterCast is in 3 of those 5 pickups. Of course, with the Ford petrol engine for the F-150, with the Ram EcoDiesel on the Ram 1500, and more recently, since about December, the Nissan Titan with the 5-liter V8 from Cummins. In total, if you were just to add the first 3 and multiply by 12 to get an annual rate, it's about 2 million vehicles per year. And because those engines are bigger and generally heavier, it comes out to being about 4 million engine equivalent market opportunity. At the moment, we're supplying about 300,000 engines per year into the sector, so we have a vehicle penetration of about 15%. So a really good penetration and still a really good opportunity to grow. We frequently receive the question, is the SinterCast market finite? Will these big vehicles be phased out? Will electric powertrains replace combustion engines? And, I'd like to take some time today to displace any hype or uncertainty about that, because the reality is much different than what we read in the media. I think if you were to ask man on street about his impression of electric vehicle penetration, he would think today we're more than 10%. And likely think that it's going to be 50% or more very soon. And in fact, that's not at all the case. None of the forecasts show that. So there's this real imbalance between the information and the reality. Some of you will remember Drew Winter, who was here, I think, 4 years ago as our guest speaker from Ward's Auto World. And he talked about technology development and how it always starts with a euphoria and then it comes to a reality. And we see here also this difference between the euphoria and the reality on the road. So let's take a moment to look at that in more detail. And I'd like to start with a quote from Margot Oge. So she was the director of the Office for Transportation and Air Quality at the Environmental Protection Agency in the U.S. She was there for a very long time, a very high-profile person in America in the decision-making at Washington and among the OEMs. And she was interviewed in the Ricardo Quarterly a year ago now. And Ricardo is one of the big three engine design consulting firms. So really the premier league of engine design companies. And her quote, she said, "The 2025 standard will be met through the use of improved internal engines. The requirement for strong hybrids and electric vehicles is estimated between 1 and 3%. What is amazing is that more can be done to improve the internal combustion engine beyond what we need for 2025. Yeah? And indeed, most forecasters predict that the internal combustion engine will still be the dominant powertrain in 2050. Yeah? And I'd like to look in more detail at what's going to come after 2025. Maybe the tailpipe emissions are so low that the incremental benefit of having lower emissions is not as big as focusing on life cycle. And maybe it would become more sensible for the legislators to focus on the total energy content of the vehicles. I think tailpipe is important. And the good thing about tailpipe is it's very easy to measure. It's very easy to understand. But I think and I hope that life cycle will come, and we'd like it to come in the form of giving credits for those who use energy efficiently in the manufacturing process. And Mark's study will certainly be one more input to the decision makers. So that from the EPA. Let's look at some other data. This is from PricewaterhouseCoopers, and they publish every quarter what they call an Autofacts report. And we'll take a moment to become familiar with this plot. So this is for North America, and we can see the current breakdown. One moment. We can see the current breakdown of gasoline, diesel, hybrid, electric vehicles and plug-in electric vehicles, and fully electric vehicles from 2015 out to 2020. And what we can see is that it's primarily gasoline all the way. Yeah. The diesel penetration is about the same as the electric and hybrid combined, and that doesn't really change in this 5-year planning horizon. Yeah. Let us, and we see at the bottom for pure electric vehicles, just a niche market entry in that time frame. We can do the same for Europe, and of course now we see a higher penetration of diesel vehicles. So here's petrol and then diesel, and again, a relatively small proportion of hybrid and electric vehicles. Some people are discussing lately that the diesel will reduce in the penetration here in Europe. I think that most people in the industry are expecting it to decline from the low 50s, maybe current 52%, down to around something like 45%. But it is not a wholesale change. It's not a change to 20 or 10%. And that's what we see here in this plot from PricewaterhouseCoopers. And again, in Europe, just a niche penetration of electric vehicles. We can do, and so it's interesting to note that in the United States, the hybrid and electric vehicle penetration in 2010 was 2.5%. And the forecast, and the reality for 2015, also 2.5%. Yeah. In the meantime, the market has increased from 10 million vehicles to 15 million vehicles. So there has been an increase in the absolute numbers, but not an increase in the uptake or the penetration rate. We can then look at the same type of a plot for Japan and Korea, what's called developed Asia Pacific. And we see here, of course, a higher penetration of hybrid and electric vehicles, a relatively smaller amount of diesels, and still a dominance of gasoline engines. Yeah. We can also see Asia data in another way, and this is from JATO Dynamics in the United States. They made a forecast for 2025, and they say that in total there will be approximately 5.5 million electric vehicles, of which 3.3 million will be plug-in hybrids. Yeah, it's not additive, but rather about 60% will be plug-in hybrids. And we can see where most of that growth is coming from. It's primarily in China. And as we all know, in the big cities in China, there is a real smog problem. And so tailpipe is extremely important in China, and rightfully so. China is therefore favoring electric vehicles in its legislation. Before you can buy a vehicle in China, you first have to get a license plate. If you ask for a license plate for an electric vehicle, you will get it quickly, and you will be able to drive it into the city 7 days per week. If you want a license plate for a gasoline vehicle, you have to wait in a lottery until it comes available, and you will only be able to drive into the city 2 or 3 days per week. If you ask for a license plate for a diesel vehicle, you won't get a license plate. Yeah? So this is the way that they are influencing the vehicle selection. So with this promotion of electrification to reduce tailpipe emissions in the cities, we see the government increasing the amount of poles or charging stations for electric vehicles. In 2014, there were 780. And in 2020, they forecast to have 4.8 million, of which half are destined to be in Beijing. Yeah? So we see this clear demand. In China, it will be electric vehicles and it will be gasoline vehicles. There isn't really a diesel market on the passenger car side. So for us, the market opportunity in China is primarily commercial vehicles and off-road applications. But I think there's a real life cycle story here, because when China is making passenger vehicles, the government can help influence in this planned economy if they make the engines from aluminum or if they make them from cast iron. And Mark has shown us that the aluminum has a much higher energy intensity. So if we make more aluminum engines, we need more power plants to supply that energy. In China, 65% of the energy is supplied by coal. Yeah? China is currently opening 1 coal-fired power plant every week. So if Mark makes that calculation as a part of his study, where we show the difference in the energy consumption for aluminum and cast iron, and more aluminum means more energy means more coal-fired power plants, and more coal-fired power plants means more CO2 emissions. And it becomes very important because it's the largest car market in the world. We're going to multiply that CO2 by 20 million vehicles per year. And so it would be very interesting to see in the conclusion of the paper a China scenario or a China case study where how much CO2 they would save by making engines out of iron, and potentially even how many fewer power plants they would be able to build by favoring iron. And this is a real advantage to China because their government can do that. We can't do that in the West. And finally, a nice summary slide, again from PricewaterhouseCoopers AutoFacts. We see the hybrid, the plug-in hybrid, the pure electric vehicle, all combined. And in 2015, it was approximately 3.6% of the market. And forecast out to 2022, not quite 8% of the market. And that doesn't agree at all with the perception of the man on the street. But this is more the reality. So the question is, if we want to make a contribution to the environment, where do we focus? Do we take that 3% of small cars that have a low fuel consumption and try to make them better? Or do we focus on the big volume of big vehicles and make them more fuel efficient? And that's what we do. We're focusing on the 30%, not on the 3%. So let's look at, we said earlier that we have 5 pickup trucks, 3 of them using SinterCast engines. Let's look at 2 of our engines. So we begin with the Ford F-150, again, the best-selling vehicle in North America. Our 2.7-liter V6 shown in the bottom picture. And the statistics. So there are 4 engine options. And we can see the power and the torque and the fuel economy in terms of miles per gallon. The miles per gallon numbers are city, highway, and combined. And what we see is that our engine has the best fuel economy. Yeah? But it's not so much the fuel economy. What we're really interested in here is the drivability. And if we look then at the power, not in terms of the total power, but the specific power, the power from each liter of displacement. Here we have 120 horsepower per liter, and in the other vehicles considerably less. And most importantly, our torque, because this is the drivability, yeah? This is the acceleration and the ability to tow things. we're approximately double of the 3.5 litre and the 5 litre naturally aspirated engines, and providing 10 to 20% better fuel economy. And this is our opportunity, this downsizing contribution, where we enable smaller and more performant and more efficient engines. Replacing the 5 litre engines with 3 litre engines that are more fuel efficient. And isn't it logical that that's the real contribution to the environment and that that's the real opportunity? And when people ask, is the market finite? The market isn't finite. The market is just starting. Yeah, this is where the growth is. We can do the same thing with the Ram diesel. Again, you see our engine in the bottom. So they have 3 engine options, our 3 litre diesel, the 3.6 litre petrol, and the 5.7 litre Hemi petrol. Again, we have the best fuel economy. The 29, the highway rating, is the highest of any pickup in North America. Indeed, the 2 engines that we're showing now are the 2 most fuel efficient out of the 12 engines that are available. That's our contribution. That's your contribution. And if we look again in terms of specific performance, the drivability, here we have 140 Newton meters per litre compared to 72 for the 5.7 litre engine, double. Yeah, it gives exactly the same drivability. Look, we have 420 Newton meters and the big engine has 410. Yeah, so it has the same drivability, but much better fuel economy, 50% better fuel economy. Yeah. So if you want to make a contribution, you take those big engines that use a lot of fuel, which are 30% of the market. You don't go and try to make a 3 or 4% contribution to 3% of the market. So that is about our production, our market opportunity, our engines, and our contribution to the environment. Let me change gears now for a moment, and on behalf of our team, I'm very proud and happy to be able to introduce the new ladle tracker technology. You will have seen that in the press release a few hours ago, and there's a simultaneous posting on our website of a technical description of the product. It's an elegant new technology. I think it reinforces SinterCast as a provider of high-tech solutions and a provider of unique solutions. And I'm very happy to share that with you today. So here we see the ladles standing on preheat. These are the radio frequency identification tags on the ladles. And this is the antenna that sits at key positions in the foundry. So the idea is that as the ladle moves through the foundry, it will pass these antennae and it will check in at each new position in the foundry. So we're going to be promoting this with the tagline, every ladle, every minute. And we're not presenting a concept here. This isn't a new idea. This is a proven product. This has been in production at the Tupi foundry in Mexico since last year. It has been successfully used for the control of more than 25,000 ladles, so it's a very robust technology. If you think of the ladle starting at a melting furnace, receiving the iron, and then moving to different stations in the foundry and being poured on the line, and then coming back to the furnace to be refilled and start again. And these tags are very robust, and we find that they're lasting for approximately 1,000 of those cycles. So again, proven and strong. If we have multiple melting furnaces, we'll be able to identify which furnace the iron started from and have a documented record of every step in the process. Tupi, of course, will also be presenting this in its presentation at the Mexican Foundry Conference next month. And there should be a technical paper together with that. I don't know if it will be in the Mexican Foundry Journal for the conference or in the next issue in July, but that will come out in the next couple of months. So here we can see the ladle at the starting point receiving iron from the furnace. This is the radio frequency tag. We see the antennae over here in the corner. It's sitting on a scale, so we register the weight, and that will be linked to the ladle throughout the cycle. And up here, a very simple signal lamp, red and green for the operators, easy communication. So at the start of the process, we can intake data, as I say, for the weight, for the temperature, and also the chemistry. These are the things that later decide how many alloys have to be added to the ladle. We can use that input to determine the next actions, as I say, either the first alloy additions, or in the case of CGI, for the correction. You know, if two ladles arrive at the correction station at the same time, the antennae will say, oh, that's ladle number 22. He needs 5 meters of magnesium. And then the next lady say, okay, that's ladle number 23. He needs 10 meters of magnesium. There's no risk of confusion. Yeah? So it is control for the foundry and confidence for the end user. Simple signal lamp communication that we showed. There is also a display screen in the operator pulpit in the foundry, but that display screen can be replicated on any of the computers in the foundry, so the manager can sit in his office and see the production in real time. We'll come back to the summary reports in a moment. So we can use this to ensure process efficiency. Here we see the ladle at the automatic pouring station, no people, the RFID tag, the antennae, we have one lower and one higher, because as the ladle tilts up, it is blocked from the lower antenna, so it maintains communication with the upper antenna when it's in the high position. And again, a simple red and green signal lamp display. You know, if the foundry produces 1,000 ladles, taps 1,000 ladles at the furnace, it would also like to pour 1,000 ladles into molds. Yeah? But it doesn't always happen that way. We always lose some. And with the ladle tracker technology, they'll know exactly how many ladles were lost, and they'll know exactly where the ladles dropped out. We can also identify bottlenecks in the process so that we can go out and attack them and improve them and eliminate them. From a process security point of view, we can ensure that every step in the foundry process was completed. If the ladle shows up in the pouring area but didn't visit step number 2, the pouring car will say, I can't pour you. You don't have all of your check marks. It will automatically be locked out. Likewise, as many of you know, that in CGI and in ductile iron, where we add magnesium as the active ingredient, the magnesium content is continually fading. And so we normally have a time limit, approximately a 10-minute time clock. And if the ladle is in the pouring car, when it comes to its 10-minute time limit, even if it isn't fully poured, the pouring car will lock out automatically. So we don't have to rely on the operator and the discipline. Again, control in the foundry, confidence for the end user. If we make 1,000 ladles, and this month we lost 20, then the foundry manager will know that, and he can set a benchmark for improvement in the next month. And he has a way of measuring the performance of each team and can establish key performance indicators to measure the improvement over the course of the year. So here we see a summary of the report. It's a very simple report. It's 1 page. I've asked Nicholas not to show it here, and so it won't be in the presentation for those at home. We've blacked out all of the data so that we don't show the data of the production. But what we can see in the top corner is the percent of ladles that go directly to pouring successfully. You can see that Tupi has responded to the measurements and implemented control actions and improved the efficiency as a result of this. In the top corner, we show the number of ladles that go through in a very visual way and the location and the reason for each ladle needing correction. So that, again, we can troubleshoot and improve the efficiency of the process. Down here we see data. It is the time of the ladle at each step in the process and the time of the ladle in the pouring. And in the bottom line, it will be the difference from time from one station to the next. So we have full traceability. And it's a very simple summary. Once the foundry manager gets used to it, I think that he can digest it in 3 or 4 minutes, and he can ask the right questions of his people. He can challenge them as to how to improve. And this is what we want to do. We want to bring unique technologies that improve process control and improve process efficiency. it's applicable to all types of foundries, but particularly to busy foundries where there's a lot of ladle traffic. And so now we launch it and we look forward to exploring that market. At the same time, it gives us an opportunity to talk about the ductile iron technology. So we've been writing about the ductile iron technology for some time. We made a conscious decision a while ago that we would focus on this technology because we regard this as a unique technology, a technology that fits very well with the SinterCast technology. And so we have prioritized that. The ductile iron development is still an option, but for now we want to allocate our technical resources and also our commercial resources to developing and marketing this product. So in summary, we have growth opportunities on both the car and the truck side. At the moment, this variation is causing a bit of flattening. The existing programs can reach 2.5 million engine equivalents. The pipe looks good and confident. Those approved programs can get us up to 3 million, and there's more in the pipe behind that. So we have this continuous growth opportunity. Back in 2002, we introduced the 5 waves. We now have series production in 4 of the 5 waves. The only one that is outstanding is the inline diesels for passenger car applications, but we remain confident that we will fill that pipe and indeed fill all of the 5 waves. So far in the year, we haven't been able to announce any new installations. That also affected the first quarter comparison because in first quarter 2015, we had 3 new installations, 2 of which were recognized in the results. But I think we will have a good year for installations ultimately. We have the Texeed system in Brazil, which will either be shipped now in the second quarter or the third quarter, just waiting for the approval from Brazilian customs to ship. And we're also discussing some capacity upgrades with other foundries, which will happen later in the year. So ultimately, it will be a good installation year. The ladle tracker launch, very exciting. We're all looking forward to that. Good that we already have 1 running in series production as a reference. On the information side, we will continue with the information as we always have. We have the annual report, the quarterly reports, and the online interviews after each report. We make a lot of shareholder presentations at events. For example, we were at a Remium Shareholder Day last month. We have individual presentations to different investors and fund managers here in Sweden, in the UK, and in North America. We're active with conference presentations and articles. Many of you will have seen the CEO interview in Stock Picker here in Sweden a couple of months ago. And there will be a new CEO interview in Diesel Progress next month. And Diesel Progress is the biggest trade journal in the United States for heavy duty and off-road applications. Inside of the article with the interview will be a pullout, and we will be sponsoring that. So this is the front cover of the pullout. Inside, it has specifications of all diesel engines produced in the world. So most readers pull it out and keep it in their file all year. And on the back cover of that is this advertisement about why to use CGI. So trying to add to this wave of awareness in the heavy-duty and off-road market. As I said, still it is our biggest growth opportunity. So through the years, we've put ourselves in the position where we wanted to be. Our technology is proven and respected. Our business is proven and profitable. We've transferred more than 70 million Swedish crowns in dividends to you, our shareholders. And so now we have proven products. We have a proven team. The team has a real energy and enthusiasm and an enjoyment of what we do. So we look forward to taking that to the next level, and we thank you for your support. Thank you.